Hello everyone. So today we are going to discuss circuit laws, and in particular we're going to look at Ohm's law, Kirchoff's current law, and Kirchoff's voltage law. So Ohm's law is simple, and you should all be familiar with these laws already. Ohm's law is very simple. It simply states that the voltage across a resistor is directly proportional to the current through it. So if you were to go in the lab and put a resistor on your breadboard and you start increasing the voltage from 0 volts up to whatever voltage you want that the resistor could handle, you would see that the graph you get when you plot the results is like this straight line graph here passing through the origin, and the resistance would be the gradient of this graph, which will be the change in V over the change in I. So very simply, that is V is equal to IR is Ohm's law. Now what this means when we draw this on a diagram like we have here on the right hand side is that if we have a resistor, then the current going through it creates a voltage drop in this direction. So the voltage arrow is in the opposite direction to the current. So what this means is that at the positive terminal we have a higher potential than at the negative terminal. So the arrow and the voltage points to the higher potential, and since the higher potential drives current to the lower potential, then the current goes in the opposite direction. So that very simply is Ohm's law. Moving on now to Kirchoff's current law. This is the sum of the currents entering a node. So this is our node here, and the sum of currents entering from all these points, if we add them up, we get 0. So the other way to state this, and the more intuitive way, is simply to say the sum of currents entering the node is equal to the sum of the currents leaving the node. Now typically if you draw all the currents going in like we have done here, that confuses students a little bit, because you think, oh well, how could all the currents enter the node? Where is it going? So you have to remember that some of these currents could be negative. So in reality, if I have, say, 5 amps in this direction, it means that it could also be represented as minus 5 amps in the opposite direction. So let's do a little example now. Suppose I have these currents I1, I2, I3, and I know that this is 5 amps and this is 2 amps. How could I find I2? So this is the question. I want to find I2 here, and I know the other two currents. So the way I could do it is I could simply say the sum of the currents entering the node here is 0. So what is the sum of the currents entering the node? I have I1 is entering, I2 is entering, and minus I3 is entering. So then I have 2 plus I2 minus 5 is equal to 0, and I could get I2 from that is equal to 3 amps. So here you see we set all the currents as going in. When I write minus I3 here, that is actually the current going in this direction, minus I3. And to move on now to the voltage law. The voltage law states that the sum of voltages in a closed loop is equal to 0. So here we have an example of a closed loop. The loop starts at one point here and it goes around and around and it comes back. It doesn't matter that we have these ends here going out. This, we could have some other circuit here on this side and on this side. It doesn't matter as long as we have a closed loop here. So what we're going to do now is look at what it means to sum the voltages across the loop. So let's pretend that we have a impedance meter and we could, sorry, a voltmeter, and we could measure the voltages across each one of these points. So I start off by placing one probe of my meter here, and I measure the voltage from this point to this point, and let's call that VR1. So if I place my probes between these 2 points, I will just get the voltage across this resistor. If I now take these probes and I measure between this point and this point, I will get VR3. And similarly, if I measure between this point and this point, I will get VR2. Now, if I measure between here, I place one probe here and I place the other probe here, I will get VR1 plus VR3. So once we have that, then what you could see is if I leave one probe at this point and I measure to here, I get VR1. Then if I measure to this point, I get VR1 plus VR3. And then if I bring it across to this point, I get VR1 plus VR3 plus VR2. But look at where we finish. This is now the same node. So if I have the 2 probes on the same node, then essentially there's no voltage difference there. So I'm going to get 0 volts. And that is the basis of the voltage law. That is essentially what it tells you. That if you add these voltages going across the circuit, going across the closed loop, then it should sum to 0 because you'll end up at the same point you start at. So now let's look at an example. So in this example, we are required to find the voltage of VR3, that is the voltage across the resistor R3. So the first thing we need to do is we need to pick a direction as positive, and here I'm going to just choose arbitrarily the clockwise direction, as positive. So now we need to take all voltages, well, this is what I'm going to do, take all voltages in the same direction as positive and all voltages in the opposite direction as negative. So let's start our loop at this point here, and the first one, if we go in the clockwise direction, the voltage is in the same direction here, so I write that as a positive. Then VR3 is in the opposite direction, and then VR2 is again in the opposite direction, and that gives us 0. So we went 10 volts, then we went VR3, then we went 5 volts, and we come back to the same node here, which means the difference between these 2 points is 0. So now to solve for VR3, I just take VR3 and put it on the other side, and I get VR3 is equal to 5 volts. So if I put VR3 is equal to 5 volts here, we will see that it means from this point, if I go this way, it is 10 volts, and if I go this way, it is 5 volts plus 5 volts is also 10 volts, which is consistent. So just in summary, the things we covered today: the 3 fundamental circuit laws: Ohm's law, Kirchoff's current law, which is looking at the currents going into a node sums to zero, and Kirchoff's voltage law, which looks at the voltage, sorry, in a closed loop being equal to zero. The sum of voltages around a closed loop is equal to zero. Next time, what we look at is combining resistances in series and parallel.